So with what we've been doing so far with subnetting, we've been focused pretty much exclusively on given some base starting network, which you can't touch, you can't modify, and then asking yourself, okay, how many networks do I actually need in my organization beyond this one? Oh, I need 8, I need 15, I need 37. Figuring out, okay, of my available host bits, how many of those do I need to steal? How many do I need to convert into subnetting bits so I can take this one network I originally got and subdivide it into more networks to fit the quantity of networks that I need. The second piece of that is, each one of those networks in your organization is going to have a certain quantity of hosts in it, right? If you're creating a network for your engineering department, if you're creating a network for your payroll department, you're going to have to also be aware of, okay, not only is that a discrete network that needs its own group number, its own network number, but I also need to be aware of how many devices within that network are going to need discrete IP addresses. How many hosts will there be in that network? And also keep in mind that whatever router is connected to that network, whatever default gateway is connected to it, that router counts as a host. That router's interface connecting to that network is going to need an IP address itself, so he recognizes that he is a host on the network. That is going to consume one of your available host addresses, so don't forget about that. So that's the second part of this is, okay, not only do I need to create my subnets and figure out what my subnet mask is, but after I create that new subnet mask, I have to ask myself, these subnets I'm creating, do they have enough host space left over for the host requirements I have in each one of these networks? If the answer is no, well, then you can't use this technique that we're using here. You'll have to use a different technique that we'll get into when we talk about variable length subnet masking. So how do you answer that question? How do you say, okay, given this particular network, whether it's my starting network or whether it's a network I've created as a result of subnetting, how many host addresses do I have available in this network? And here's the formula to answer that. You take, actually, hold on a second. This is incorrect. This is incorrect. I need to change this. You're not talking about subnetting bits at this point. You're talking about host bits. There we go. That is more accurate. 2 to the power of h minus 2. So when determining how many subnets am I going to have available, you took a look at those bits you converted into subnet bits, like I converted 3 bits into subnetting bits, and I said, well, with 3 bits of subnetting, 2 to the power of 3 gives me 8 combinations, 8 networks I could have. Now you're taking your gaze, your focus, and you're shifting it away from your networking bits, and now you're looking at the bits that are left. You're looking at your host bits that are left over, and you're saying, okay, how many host bits do I have? If I've got 9 host bits left over, if each one of those subnets I've created has 9 host bits left over at the end, I say, well, with 9 host bits, 2 to the power of 9 minus 2 gives me how many hosts I have available. Now you might be wondering, well, why minus 2? Well, the last part of the slide here demonstrates that, because remember, of your host bits, 2 of those available patterns are not accessible for assigning to hosts. The all zeros host and the all ones host, the network and the broadcast, are not usable. So that's why you don't have every possible combination of hosts available. You have every possible combination but 2, minus 2. So 2 to the power of h minus 2 gives you your available hosts. So based on that, let's do a few more examples, or I should say a few more exercises. Get everything lined up here. All right, so here do we go. Given the following subnet mask, how many hosts can fit in this subnet? What's the total quantity of hosts you have available based on this subnet mask? All right, so in this particular example, our correct answer is B. 62 hosts. So with this particular subnet mask, it's telling us that of our entire 32-bit address, most of it, 26 bits, are networking bits, are reserved for the network, for the group, which only leaves us with 6 bits left over for host bits. Well, 2 to the power of 6 gives us the number 64, and when we subtract 2 from that, that gives us 62. Let's do another one. An ISP leases you the following network. You need to create 22 subnetworks from this single network. What will be your new subnet mask, and how many hosts will be supported in each subnet? All right, so the answers for this are A and E. Good job for those of you who selected that. So with 22 subnetworks, okay, so let's see, stealing 1 bit will give me 2 networks, 4 networks, 8, 16, almost there, 32. So I need to steal 5 bits to give myself at least 22 networks. So if I take 5 bits and I add it to a /23, 23 plus 5 is a /28. And with a /28, that'll give me the first subnet mask. 255, 255, 255, that gives me 24 bits, and then 240. If I draw that on here, that's 1, 1, that's 224 plus 1. So that gives me my 28 bits. First 23 plus the 5 bits that I stole gives me 28 bits. Which leaves me with 4 host bits left over. 2 to the power of 4 minus 2 gives you 14 hosts. An ISP leases you the following network. You need to create 22 subnetworks from this single network. See if you can answer all 4 of those questions. Okay, I gave you a little bit of extra time on that one because it's basically 4 questions rolled into one. Here are the answers. Okay, so we start out with a /24. To make 22 networks out of that, it was just basically like the previous question that also was 22 networks. We needed to steal how many bits? 2, 4, 8, 16. We need to steal 5 bits. 2 to the power of 5 gives us 32. So that gave us our new subnet mask of /29, which in dotted decimal is this. That tells us the first 29 bits are networking bits. With the /29, that means we have 3 host bits left over. 2 to the power of 3 is 8, minus 2 is 6 hosts. What is the subnet address of the 4th subnet? Let me actually show you. I've been holding off on this little tidbit until now. A little cheat sheet I developed to help identify this kind of thing. Right here. This is what I call my subnetting cheat sheet. Everybody's got a different way of doing this. You'll probably find dozens of similar types of things if you Google it, but this is just one I came up with. And this is the way I work it. So in the previous example, we figured out, it said I needed 22 subnetworks. 22 subnetworks. So if I use this, I say, okay, well, the numbers in green here represent how many networks are available. So if I need 22 subnetworks, that means I'd have to go out to right here. So that means I would need a /29. So putting my dividing line right here gives me 32 networks, so a /29. And then if I look just to the right of that line, that gives me how many hosts are available. So basically the way you create this from scratch is this, and this is really useful if you're just subnetting into the last octet, into the fourth octet. You just say, okay, in that fourth octet, let me just put my numbers in binary here, 1, 2, 4, 8, 16, so on and so forth. Then draw lines separating each bit. And so for here you can see, okay, well, if I steal 1 bit, that's a /25. If I steal 2 bits, it's a /26. So that's where you come up with your blue numbers up here. This is your shorthand notation for your subnets. And you can see here, okay, now I just start doing binary, 2, 4, 8, 16, 32. This tells me, okay, if I have a /25, it gives me 2 networks. If I have a /30, it gives me 64 networks. If I have a /27, 8 networks. So now you've developed how many networks you get for each one of these subnet masks. And then you take a look at your original binary number, subtract 2 from it, and put it to the right of the line. Remember, from the right, rearmost, we discover our hosts. So that gives me 126. 64 minus 2 is 62. 32 minus 2 is 30. So now, once I've decided what my line is going to be, I can look to the left of it to discover how many networks I have available, and I can look to the right of it to discover how many hosts I have available given that particular subnet mask. So in this particular case, when we saw that I had, oops, let's go back to here. When I was going to be doing a /29, right, 255, 255, 255, 240, that's /29. So right here with the /29, when I look just to the right of the line, that gives me 6 hosts. And indeed, that was this correct answer right here, 6 hosts. Now, one other thing you can use this for was the subnet address of the 4th subnet. If I go back to this, once I know where my dividing line is, like for example, /29, the dividing line is right here between where the network ends and where the hosts begin. Look at the binary number just to the left of that line. In this particular case, it's the number 8. This tells you that all of your subnets are going to be in multiples or increments of 8. For example, you're going to start out with subnet 0, 0, 0, 0, 0, 0, and then it's going to be 0, 0, 0, 0, 1, well that's the number 8, 0, 0, 0, 1, 0, that's the number 16, 0, 0, 0, 1, 1, that's the number 24. What do they all have in common? They're all in increments of 8s. If you came up with a subnet mask that was a /27, well, just looking to the left of this line, all of your subnets are going to be in multiples of 32s. They're all going to be in multiples of 32s. So in our particular case, where's my cursor? There it is. We came up with 255, 255, 255.248. Which was equivalent to a /29. So there's my last octet. Put in my binary numbers. Nope. Hold on a second. I think I'm missing something. I think I only had 7 patterns. 1, 2, 3, 4, 5, 6, 7, 8. All right, there we go. So here we've got 128, 64, 32, 16, 8, 4, 2, and 1. Okay, and when I put my dividing line as a /29, which was right here, so I got 24 bits plus 5 /29. Now I know that all of my networks are going to be in increments or multiples of 8. So my first network, see what they say, the original starting network was 199.10.1. 199.10.1. And I can't change that. So the first network is going to be .0, that's my first subnet. And now my next one in multiples of 8 is going to be that. My next multiple of 8 is going to be that. That's going to be my next multiple of 8 there. Let's just do one more. That's my next multiple of 8. And the question was, what is the subnet address of the fourth subnet? Well, we just figured that out. Here's the first, second, third. So this was the subnet address of the fourth subnet right there, 10.1.24. That's what led to this. What is the broadcast address of the sixth subnet? Okay, well, let's keep going. We've already got the fifth one. The sixth one will be that. Let's just go one more to the seventh one. That's the seventh subnet. So if this is the IP address, if 1.48 is the IP address of the seventh subnet in binary, one less than that would be the broadcast address or the very last address of the previous network. Well, what's one less than that? 199.10.1.47. So that is the broadcast address of the previous or the sixth subnet. And that's what gave us this number. So if you didn't have a chance, let me just let you take a screenshot of that for a moment. I'll get rid of this circle here. And using that, let's see how well you fare on this next question. Same type of question. Go ahead and read through that. So let's go through each one of these. So we need 59 subnetworks from this single network. Okay, so let's just use my fingers here. 2, 4, 8, 16, 32, 64. So I'm going to need to steal 6 bits. So if I take my original 21 bits and I add 6 bits to it, that gets me a /27. So let's go over here. And we'll just put a red circle around /27. So that's where we are. So based on that, what will be our new subnet mask? 255.255.255.224. That's equivalent to a /27. How many hosts will be supported in each subnet? Well, take a look at this. Go down to the bottom right. 30 hosts. That's the number just to the right of that line. 30 hosts. What will be the subnet address of the fourth subnet? Well, looking at this with a /27, my subnets are always in increments or multiples of 32s. So the first subnet will be the 0 subnet, and then the 32 subnet, the 64 subnet, and the fourth subnet will be the 96 subnet. The 96 subnet. What will be the broadcast address of the sixth subnet? Well, if we kept on going, adding 32 plus 32 plus 32, if we went up to the seventh subnet, we would have seen that that was the 8.192 network. And if we back off 1 from that, that gives us .191, which would be the broadcast address of the previous or the sixth subnet that was right before it.